You know that feeling. When you're faced with something huge, complex, like assembling furniture with a million parts and instructions that barely make sense, sometimes programming feels like that too. Just staring at a blank screen, thinking about all the code you might have to write. But what if I told you there's this massive, really well-organized toolbox out there, full of ready-made tools, tools that can handle a huge chunk of that work for you?
That is exactly what we're going to explore today. We're
Yeah.
taking a deep dive into one of the most powerful, well, shortcuts maybe isn't the right word,
Hmm.
resources available to C-sharp developers. The .NET Class Library. Think of it just like that toolbox you mentioned, or maybe a massive public library. It's expertly curated, ready to help you tackle almost any programming challenge.
And the learning materials we're looking at today, they're all focused on getting started with this library, right?
Exactly.
So this isn't just, abstract theory. It's about getting practical skills you can use right away to build actual applications. It's like getting the keys to this amazing workshop.
Yeah, our mission really is to demystify this thing. It seems vast, and it is, but we want to show you how understanding it, how using it, can seriously speed up your development and let you build apps with way more features than you might think you could manage alone. We're talking about finding these pre-built solutions for, well, tons of common programming problems.
Okay, let's get into it then. What exactly is this .NET Class Library? Break it down for us.
Okay, imagine walking into a huge library, not just books, right? This library has tools, blueprints, maybe even pre-made components for building things, meticulously organized. The .NET Class Library is, well, it's a lot like that. It's this enormous, organized collection of pre-built programming resources. We call them classes. And inside these classes, you find reusable pieces of code called methods. These methods perform specific actions. So using the library isn't just about code reuse. It's leveraging decades of problem solving by Microsoft engineers. Best practices, optimizations, stuff that's hard to replicate on your own.
That library analogy really helps, gives a sense of the scale. So instead of writing everything from scratch, we have these classes and methods just waiting.
Pretty much, yeah.
Can you give a concrete example, something maybe we've bumped into already without realizing it?
Oh, definitely. If you've written even the simplest C-sharp program, like Hello World, you've used it.
How?
You probably use the console class. It's a fundamental part of the library. It provides methods like WriteLine, that's the one that displays text on your screen, and others like read, or readline, to get input from the user. That classic console WriteLine, hello world, that's you using a pre-built method from this library.
Right. Okay, so console is like a specific department in the library all about input and output.
Exactly.
And WriteLine is like a specific tool in that department.
You got it. A class is basically a container for related methods, like sections in the library for related topics. And what's really powerful is how broad this library is. It's not just for simple console apps. It has building blocks for, well, pretty much everything. Web platforms, desktop software, mobile apps, cloud services. You find really specialized classes for niche things, but also tons of general purpose classes for fundamental tasks.
It sounds like a massive time saver for developers. You don't have to keep reinventing the wheel.
That's the whole point. Microsoft puts a huge effort into building and updating this library so developers can focus on what makes their application unique, not the common plumbing underneath. And here's something that might surprise you a bit. Even the most basic data types you use constantly, like string for text, int for whole numbers, they're actually classes defined in the .NET Class Library.
Hang on, really? So when I type in my number E5, I'm actually using a class from this library. That feels
Okay.
fundamental.
It is. C# just gives you these convenient shortcuts, these aliases like int and string. Makes code cleaner, more intuitive, but underneath, yep, they're classes. And because they're classes, they come with built-in methods. Take string, it has super useful methods like toUpper to make text uppercase or a to lower for lowercase. Those are just built right in because string is a library class.
Wow, okay. Even declaring a number is tied into this huge library. That definitely changes how you think about the basics. But, I mean, if it's that big, how do you avoid getting lost? How do you find the specific class or method you need for a particular job?
That's a really good question. It can feel daunting. But back to the library idea, you don't need to memorize everything. You just need good strategies to find what's relevant. Often, the best first step when you hit a programming problem is just use a search engine. Seriously. Search for what you're trying to do, like C# format date string or C# read file. You'll almost certainly find blog posts, forum discussions, articles, where other developers solved similar things, and they'll often point you straight to the .NET classes and methods they used.
Ah, so tap into the community knowledge. See what tools others used for the same problem.
Exactly. Beyond that, though, the absolute best resource is Microsoft's own documentation. The C# language reference and programming guide on learn.microsoft.com, that's the definitive source. The documentation team works right alongside the .NET developers, so it's accurate, it's up to date. You'll find detailed explanations, examples, how methods work, limitations. Think of it as the official library catalog and instruction manual.
Right. Go to the source for the official word. Makes sense.
Absolutely. And, don't underestimate just trying things out. Build small test projects. Experimenting is probably the best way to really understand how things work together.
Yeah.
Getting your hands dirty.
Okay, great strategies. So we know what it is,
Yeah.
roughly how to find things. Now, how do we actually use these methods in our code? What's the basic syntax?
The most fundamental way is class name, method name. You use the class name, then a dot. That's the member access operator, then the method name, and finally parentheses. Those parentheses are key, even if the method doesn't need any extra info.
Got it, like console.writeLine.
Yeah.
You've seen that. But the materials also mentioned stateless versus stateful methods. What's that about?
Ah, yes. That's a really important distinction. Stateless methods, which are often called static methods, don't depend on any particular state or data your application might be holding on to. They just do their job based on the input you give them, if any. They don't change or rely on stuff stored in memory from previous operations. Think about console.writeLine again. You give it text, it prints it. It doesn't need to know anything else about your program's history.
So it's like a self-contained little function, doesn't need context.
Exactly. Now, stateful methods or instance methods are the opposite. They do need to access or maybe even change the application state. They work with data stored in memory. Often this data is held within the class instance itself, in special variables called fields. These fields store the object's current information, its state. A classic example of a stateful method is random. Next, the one for generating random numbers.
Okay, so random, next, needs some context. It needs to know something about the random number generator's current situation. How do we provide that?
Right. To use a stateful method like next, you first have to create an instance or an object of the random class. You use the new keyword for this. Think of the class random as the blueprint. The object is the actual thing you build from that blueprint. When you use new, you're asking the computer for memory, telling it to create a random object there based on the blueprint, and then it gives you back the memory address where that object lives.
So it's like saying, hey, computer, build me one of these random things using the plan and tell me where you put it.
Perfect analogy.
Yeah.
You then store that address in a variable. So you might write random dice, new random, or the short newer way, random dice, new. Now, dice isn't the blueprint anymore. It's a specific, actual random object living in memory.
And now we have this dice object. We can call the stateful next method on that object, like dice next.
Exactly. Now you're interacting with that specific instance. And it's interesting to think why random next needs to be stateful. Why isn't it just static like console WriteLine? Well, computers aren't naturally random. They're deterministic. To fake randomness, the random class usually uses the system's current time, down to the millisecond, as a starting point, a seed value. It feeds this seed into a complex math algorithm that produces a sequence of numbers that look random. The state that the dice object keeps track of is related to that seed and where it is in the sequence, each time you call dice. Next, on the same object, it uses its current state to generate the next number in its sequence. If you made a new random object, say random coin ixus new, it would probably start with a slightly different time seed and generate a completely different sequence.
Huh. That's fascinating. So it's tracking its internal state to make the next number seem random relative to the last one.
Okay.
But how do we know generally? When we encounter a new method, how do we know if it's static or if we need to do that new thing first?
The absolute best way. Check the official documentation on learn.microsoft.com. The docs for a method will almost always show examples of how to call it either directly from the class or by creating an instance first.
Okay, so rule #1 is check the docs.
Always. But if you're just experimenting, you can try calling it directly from the class name, like classname.methodName. If it compiles and runs, great, it's probably static. If you get a compile error in, say, Visual Studio Code, that's your clue. You need an instance.
What kind of error would we see? Like if we tried random next directly?
Sure, if you just wrote int result random.next,
Mm-hmm.
your editor would likely flag random next. Hover over it, and you'd probably see something like, an object reference is required for the non-static field method or property random next.
Yeah.
That error message is basically saying, whoa, next isn't static. You need an actual random object to call this on.
Got it. The error tells you pretty clearly. Okay, so after a method runs, does it always just do something, or does it sometimes give us information back?
Good question. There are two main types. Some methods are void methods. They perform an action like console.writeLine, and then they just finish. They don't return any value back to the code that called them. It's like a one-way street.
Send it info, it does its job, end of story.
Exactly. But other methods are designed to return a value. This value is the result of the method's operation. It could be an int, a string, a boolean, even another more complex object. Returning a value is how a method communicates back. We already know random next returns an int, the random number it generated.
And if it returns a value, we need to do something with it, right? Catch it somehow.
Usually, yes. The most common thing is to assign the return value to a variable. Like we saw, int roll with dice, next 1, 7. The int value returned by next gets stored in the roll variable. Or you can use the return value directly. Maybe pass it straight into another method. Console, writeLine, dice, next 1, 7.
Right.
No temporary variable needed there.
Okay, store it or use it immediately. Makes sense. Now looking at dice. Next, 1, 7 again. Those numbers inside the parentheses, the 1 and 7, what are those officially called?
Those specific values, 1 and 7, are the arguments you're passing to the method when you call it. The method itself, in its definition, declares parameters. Parameters are like named placeholders for the arguments the method expects to receive. Think of parameters as the requirements listed in the method's blueprint. I need a minimum value, I need a maximum value, and arguments are the actual materials you supply when you build. Here's 1, here's 7.
Ah, parameters define what's needed. Arguments are what we actually give it. So next, 1, 7 uses arguments 1 and 7 to satisfy parameters for a minimum and maximum.
Exactly. And even console writeLine hello takes an argument, the string hello, which matches its parameter definition. It expects something it can display. And crucially, the C# compiler checks this for you. It makes sure the data type of the argument you provide is compatible with the data type the parameter expects. If a method expects an int, you can't just give it a string. The compiler catches that mismatch, preventing runtime errors.
That's handy. The compiler helps keep us honest.
It does. Now, related to parameters and arguments is another really useful concept: overloading.
Overloading sounds complicated.
Not really. It actually adds flexibility.
Yeah.
Overloaded methods are just multiple methods in the same class that have the exact same name, but differ in their method signatures. The signature is basically determined by the number of parameters and the data types of those parameters.
So multiple versions of the same method name, each designed for slightly different inputs.
Precisely. It lets you call the method in different ways depending on what information you have or what specific behavior you need. Our old friend console writeLine is a prime example. The learning materials mention it has something like 19 different overloads.
19 versions of writeLine. Wow.
Yeah. That's why you can just pass it an integer or a string or a boolean or lots of other types. The compiler looks at the argument you provide and picks the correct writeLine overload that knows how to handle that specific data type.
Ah, that makes so much sense now why it just seems to work with anything.
Exactly. Look at this simple code. C# int number int 7, string text equals 7. Console writeLine number calls the int overload. Console writeLine calls the overload with no parameters, prints blank line. Console writeLine text calls the string overload. 3 calls to writeLine, but behind the scenes, 3 different overloaded versions are being used based on the arguments.
The compiler is smart enough to figure out which one we mean. That's cool.
It is. And overloads don't just differ by data type. They can differ by the number of parameters, too. This often gives you finer control. Random next is a great example here as well. It has at least 3 common overloads. Next, with no arguments, returns any non-negative random integer. Next, max value, with 1 integer argument, returns a non-negative random integer that's less than max value. And next min value, max value, with 2 integer arguments, returns a random integer between min value inclusive and max value exclusive.
So depending on which overload we call and which arguments we give it, we get different ranges for our random number. The sources showed an example comparing the output of these.
It's exactly right. Understanding overloading is really key to using the library effectively, because you can choose the variation that best fits your exact need at that moment.
This is incredibly useful. But, when you're deep in code, how do you easily see these overloads? How do you remember if it's next or next max or next min max without constantly flipping back to the docs? There must be a better way right in the editor.
Oh, absolutely there is. That's where your IDE, Your integrated development environment becomes your best friend. Specifically, IntelliSense in Visual Studio Code. IntelliSense is amazing for exploring methods without leaving your code. As you type, it pops up with smart suggestions, code completions, hints about parameters, quick info.
Like a little coding assistant right there with you.
Totally. So let's say you have your dice object, random dice in new. If you then type dice, the object name followed by a dot, IntelliSense will immediately pop up a list of all the methods and properties available on that dice object. If you then type N, it will filter that list down, and next will probably be right at the top. You hit Tab, and it completes the word for you.
Definitely speeds things up.
For sure.
Yeah.
But the real magic happens when you type the opening parenthesis after next. IntelliSense then shows you detailed info about the next method, its return type, a quick description, and crucially, it shows you the available overloads. You'll often see little arrows or text like 1 of 3, indicating there are multiple versions. It shows the parameters for each overload, their types, their names, and maybe a short description. You can usually use your up and down arrow keys to cycle through the different overloads right there in the pop-up.
Whoa, okay, so right in the editor, as I'm typing the call, I can see, there's one with no arguments, one with 1 int, one with 2 ints, and see what each parameter means. That's a game changer.
It really is. IntelliSense is fantastic for that quick, in-context help. But remember, learn.microsoft.com is still the ultimate source of truth. For the deepest details, edge cases, explanations of exceptions like argument out of range exception, complex examples, the official docs are unbeatable. Just search C#random.next. Find the Microsoft page, look for the overload section. It lists everything meticulously.
Okay, IntelliSense for quick help, docs for the deep dive. Got it.
Right. So let's try to put this together with a quick challenge.
Yeah.
Imagine you have two numbers, say 500 and 600. C#. Int first value equals 500. Int second value equals 600. Int larger value. We need code here. Console write line, larger value. The challenge is find a method in the system. Math class using IntelliSense or the docs that takes two numbers and tells you which one is bigger. Then call that method with first value and second value, assign the result to larger value so that the console write line at the end prints 600.
Okay, a little detective work. Find the right tool in the math classes section of the library to compare two numbers and get the bigger one back.
Exactly. Give it a shot mentally, or maybe try typing math in an editor if you have one handy.
Math. Maybe something like max.
You got it. The solution is larger value equals at max, first value, second value. And just like the others, MathMax is overloaded too. It can handle integers, decimals, doubles, other number types. The one we use takes 2 ints and returns an int. It's a simple example, but it shows how the library gives you these ready-made solutions. No need to write your own if statement to compare them.
Just call MathMax. That really drives home the efficiency gain.
Absolutely. And that kind of brings us towards wrapping up our deep dive for today. Let's maybe summarize the key points.
Sounds good. It was a lot to cover.
Yeah, it was. So first, the .NET Class Library is this massive, organized collection of pre-built code classes and methods ready for us to use. Saves tons of time. We looked at the C# syntax for calling methods and that key difference between stateless or static methods you call directly from the class and stateful instance methods where you need to create an object first using new.
And we saw how crucial tools like IntelliSense and VS Code are for exploring these methods and their overloads right as we code. Plus, the official docs on learn.microsoft.com is the ultimate reference.
Right, and understanding things like return values, parameters versus arguments, and how overloading gives us flexibility. It's just amazing when you think about the sheer amount of engineering effort packed into this library. All these pre-built, tested, optimized components.
The scale of it is impressive. And countless real-world apps rely on it every single day. So by learning how to navigate and use this library, you, the listener, are really starting to grasp how professional software gets built. You're unlocking a huge potential for your own projects. What could you build now? What problems could you solve using these pre-built tools? Maybe take some time, browse the documentation for classes related to things you're interested in. Dates, files, networking, math, and just see what's possible. Explore and experiment.